Thanks for coming over to check out this in-depth walkthrough. We've got the Arduino powering everything over here, powered up, and then the two power rails on this breadboard have different voltages. So this rail here is hooked up to the output of this LM317 chip, which is putting out about 6 volts onto this rail, and that is grounded to the Arduino so that all our grounds there are common, and it's hooked up to both of the power inputs to the servos. This power rail here isn't, the positive line's not being used. The ground line is hooked up to all the grounds of the sensor as well as our LED. The sensors require 5 volts in, so they're hooked up to the 5 volt output of the Arduino. And we've got an LED hooked up here just to tell us whether or not the system is operating, and that's hooked up to digital pin 2. The sound sensor here is hooked up to digital pin 4, while the motion sensor is hooked up to digital pin 3. On the sound sensor, there is a small potentiometer on the front of it here. Adjusting this adjusts the sound trigger level, so either super quiet or super loud, the amount of sound that's needed to trigger this thing. On the motion sensor, there's 2 potentiometers. One controls the amount of movement that's needed to trigger it, or the distance away it looks for. So that one I've got set to maximum sensitivity. And then the other one, that's this one here. This one's set to maximum sensitivity. And this one is how long the sensor continues sending a high signal to the Arduino after it's been triggered. So I've got this one set to just above minimum. Minimum is 3 seconds, maximum is 5 minutes. I don't want this thing shooting for another 5 minutes after I walk out of the room. So I've got it set to a reasonable amount where if you're still kind of doing something, it continues to pick you up. And then on the side of the motion sensor here, there's these jumpers. And with the jumper in this position, that timer resets every single time it sees motion. So the timer starts counting down, it sees more motion, and it loops back to the top. If you put the jumper in the other position, like this, now this motion sensor, instead of counting down and then sending and resetting its timer, it gets motion, triggers its timer, counts down, and then once the timer's finished, it sends a low signal and then looks for motion again. So I didn't want that happening. I wanted it resetting every single time, which is why I've got it in this position here. Other than that, there's really not that much to this thing. What's cool with blocks and sensor blocks like this is they don't require a whole lot of hassle to hook up. You basically just plug them in. They work off the onboard voltage of the Arduino. You plug them in, they show up basically as buttons. These things are just building blocks. They're super, super easy to hook up. And there's really no fuss when it comes to hooking any of this stuff up. It's super easy to program, again, because it's just buttons. The servos run off a servo library, so you don't have to do much with that. You basically just send them to the degree you want them to spin to, and they spin to that. So it's just about how you work out your while loops to make the program do whatever it is you want it to do.
So we're just going to dive into an in-depth look at the code that's actually driving this thing. So this can be found, there's links for it in the video description, and well, you can get this for yourself and play around with it. But basically what's going to happen here is at the beginning we need to include the servo library so that the Arduino is going to know how to power or how to control the servo. And then because we're using 2 servos, we have to create 2 servo objects. So that's my servo 1 and my servo 2. And then we start initializing our initial parameters for stuff. So we're going to tell servo, we're just going to create 2 different position variables. One's going to be for servo 1 and one's going to be for servo 2. So servo's 1's going to go to reset to 0, and then servo 2, for in this case, is going to be set to 45 degrees because I only want the second servo making a pan from 45 degrees to 90 degrees, not doing a full 180. So then we go and it continues on. We initialize the sound input, we initialize the motion input. These two are just going to be used to tell whether or not the buttons have been pressed. So that'll be basically buttons for sound input and buttons for motion input. Then there's an LED light on pin 2. So these ones, because they're constant initialized, those are pin you're initializing. Because these ones have constant initialized, these are actually pins that are being assigned to sound input, motion input, and LED, whereas these are just variables that are being initialized. So we've got a timer, the direction, and a count. So then we go through our void setup. In this, we just set up our pin modes to sound input to input, motion input to input, and finally our LED to output. And then we attach pins 9 and 10 to my servo 1 and mine servo 2. So this just tells the Arduino that the servos are plugged in to pins 9 and 10. And then our whole control loop starts. So this says that, well, the direction is equal to 0. So this is our direction control. And the position of motor 1 or servo 1 is less than 180 degrees, the maximum range of that servo. It digital writes the LED pin high to tell us that the program is working. And then if the digital read sound input is high, and reset the timer to 0. And then we'll get back to this little block in just a second. Then it writes the position of servo 1 and it writes the position of servo 2. So that moves the servos to whatever position is next. We're starting at position 0 and 45. So it'll write those positions of servos. Then it will add 1 degree to the position of servo 1. And then it will take that position of servo 1, divide it by 2, and then add 45 degrees to it to get the position for servo 2. We'll then rewrite those variables, loop down, and as long as the motion input and sound inputs are still high, it will loop back and go through this again. Again, we have another one of these if digital read sound input high timer loops. You're going to see that these are throughout this code. Again, we'll talk about those in just a bit. But now this is the part that actually controls whether or not this sensor or this time-lapse base continues to rotate. So, well, timer less than 10,000, or that's what these two mean. Well, the digital read input of motion input is high, and well, count is less than 10,000 or than 1,000. So this is a timer. This is based on the time since the last sound input was sensed. So that's what these if statements that are sprinkled throughout the code are doing. They're listening for sound, and if sound is detected, they're going to immediately reset this timer, and this timer is added to right here while it's going through its delay. So this is what the sound sensor only registers high inputs when it hears sound, but obviously there's going to be times when it's not registering sound, so you do need some sort of counter on it to time how long it's been since the last sound was heard. So that's what's going on here. And then the reason we're using an OR statement is that we don't want this triggering if the room is quiet but there's motion. We want this triggering only if both these variables, both that there's no sound in the room and that there's no movement in the room, are true. We want both of those to be true in order for the, or we want, sorry, if either one of those is true, we want this base to continue rotating. So this Boolean operator here is an OR, and it means that inside these set of parentheses right here, it means that if either one of these two statements is true, this entire statement is true. And then this AND, well, this one also needs to be true because this is the actual count for the delay between little 1 degree rotations. Now mine right now is set to 1000. That's a bit fast for a long time lapse. It does its entire rotation in a couple of minutes, but I did that for testing just so I would have a better idea of whether or not this entire thing was functioning. But if you want to do longer time lapses, this variable right here is the one you want to increase. You want to increase that instead of the delay down here between adding to the count and the timer, because you want this to stay small so that the timer here works and that you don't miss sound inputs, because during this loop the sound sensor is continuing to look for sound in order to reset that timer. So basically this while loop runs, and once it reaches a count of 1000, assuming that there's sound in the room, it's going to reset its count to 0 and the loop is going to move on. This little while loop here, this is where the code will go if both of these statements in the initial Boolean operator up here, our motion sensor and our time sensor operators, if those both become false, it will get bumped into this while loop here. And this one is basically just a waiting loop that makes the program wait until it senses motion or sound again, and then it will bump right back and go back through this loop again. And this is all of this is happening inside this direction equals 0 and position equals 1. It's doing that because we want this thing to pan back and forth. So once the servo reaches a position of 180 degrees, it's completed its rotation and it's time for it to pan back. So that will end this while loop right there. The direction variable will be set to 1, telling us we're going in the other direction, and this while loop down here will start. Now this while loop is identical to the one above, except for the fact that the position of servo 1, instead of increasing every time it runs through, is decreasing. But everything else here is the same. And once this while loop is satisfied, and the position of servo 1 is less than or equal to 0, the direction is reset to 0. This while loop is ended, the direction resets to 0, and the entire program loops back and goes through the first pan again. So this is just going to take the motor, and it's going to rotate it right, and it's rotate it left, and it's rotate it right and left, and it will continue doing that forever. If you want to change the speed at which the camera base rotates, again, you can increase or decrease this number here. And if you want to change how much the tilt servo changes in relation to the rotating servo, you can change this variable right here, the amount that the position of servo 1 is divided by. So you could make that maybe 4, and that means that while these servos only work in 1 degree increments, this will end up with some rounding. So this means that every 4 movements of position 1, you'll get a movement of servo 2. So guys, there's the code. It's super simple. You can pretty much understand everything that goes on. It's just a whole bunch of little loops stacked together. And if you got any questions about it, leave them down below. I'm happy to help out as best I can. Like I've said before, I'm not an expert in this stuff, but I am tinkering. So if you've got better ways to do it, I'm sure that you probably do. Anyway, until next time, thank you very, very much for watching.